This video will demonstrate how to troubleshoot an online Prometheus application maxing out the CPU. This application is compiled with Go. Let's start by running the top command to check the CPU usage. As shown, the Prometheus process consumes 160% of CPU cores. Run the ps command to see the full command line for this process. We can see it is the standard Prometheus binary executable shipped with the Linux distribution. Let's use OpenResty X-Ray to check out this unmodified process. We can analyze it in real time and figure out what's going on. Open the OpenResty X-Ray web console in the web browser. Make sure it is the right machine you are watching. You can choose the right machine from the list below if the current one is not correct. Go to the guided analysis page. Here you can see different types of problems that you can diagnose. Let's select high CPU usage. Click on Next. Select the Go application. Select the process consuming more than 125% of the CPU resources. This is what we saw previously in top. Make sure that the application type is right. Usually the default should be correct. The language level is just Go. We can also set the maximum analyzing time. We'll leave it as 300 seconds, which is the default value. Let's start analyzing. The system will keep performing different rounds of analysis. Now it's executing the first round. The first 2 rounds are done and it's on to the third one already. That's enough for this case. Let's stop analyzing. It shows that the system is generating a report. We can see it automatically created an analysis report. This is the type of problem we diagnose. It's CPU. As you can see, the Go garbage collection takes up to 99% of the CPU time. For example, this Go code path where garbage collection is performed takes up to 21% of the CPU time. The Go runtime function scan object belongs to the garbage collector. It scans GC objects in the heap and marks reachable ones. The function GC drain is used to drain the work queue of GC objects that need to be marked. Fast allocation of many GC objects incurs high GC overhead. So the report shows the hottest Go code paths allocating the most objects with the highest speed. Now let's check the number 1 Go code path that allocates the most GC objects. The function load_WAL is loading data from the write-ahead log in Prometheus. The function series decodes time series data from the buffer and appends to the given slice. The function sliceByte to string converts a slice of bytes to a string. Click more to see more details. This code path was automatically inferred from this Go GC object allocation flame graph. Below are more explanations and suggestions about the issue. It mentions the function load_WAL. And this function is loading data from the write-ahead log. It also mentions the function series. And the function sliceByte to string. Let's go back to the code path. Hover the mouse over the green box for the function load_WAL. We can see its source file and the full path for this file in the tooltip. The source line number is 141. Click the icon to copy the full Go source file path for this function. Use the Vim editor to open the source file. And look at the Golang code in this file. You can use any editors you like. Go to line 141, as OpenResty X-Ray suggested. The function dec.series is to decode a set of time series from a record. On the status bar, you can see that this source line is inside the load_WAL function as shown in the report. The TSDB of Prometheus creates a memory series to manage the most recent data. The number of GC objects newly allocated by this code path exceeds 19% of the total new allocations. And we can see here that dynamically allocating new GC objects takes up almost 11% of the CPU time. So such allocations not only incur high garbage collection overhead but are also expensive themselves. OpenResty X-Ray can also monitor online processes automatically and generate analysis reports. Go to the Insights page. You can find the automatic reports on the Insights page for daily and weekly periods. For this reason, you don't have to use the guided analysis feature. Guided analysis is useful for application development and demonstration purposes. OpenResty X-ray is a non-invasive diagnostic system based on our own dynamic tracing technology. It can monitor and scan various kinds of problems in real time. For example, performance bottlenecks, stability issues, errors and exceptions, as well as security vulnerabilities. If you like this video, please follow us on YouTube. Thank you.